Assalamu alaikum. In this video, I will be explaining the RFID Door Lock project schematic diagram. So let's start. The main microcontroller of our project is Arduino Nano. Everything in this project connects with this Arduino Nano. We have a 12-volt connector for power input. The positive terminal is dominant. The positive terminal of this connector is defined as VCC and the negative terminal is defined as ground. We have three capacitors across the VCC and ground pin, and we don't have any external 5-volt regulator for this project, as the Arduino Nano has a 5-volt regulator which can deliver up to 200 milliamps of current easily, and we only need 5-volt current for this buzzer, for driving this buzzer. And here this LCD display connectors, and the LCD display with the I2C module actually draws less than 2 milliamps of current, and the buzzer draws 35 milliamps of current at most. So it's not necessary to connect any external 5-volt regulator, but we have connected two capacitors across the 5-volt connector. For more stability, the value of these capacitors can be changed accordingly by monitoring the performance, and we can actually ignore all these capacitors if we don't need stability or if we want to lessen the cost. So let's jump into the deep. Here I have connected a reset pin. The Arduino reset pin is active low, so there it is connected with ground across a resistor, and the VCC is the power pin, power input of the Arduino. I have connected a diode across it so that there is no loading on the regulator, 5-volt regulator of the Arduino, or less loading you can say. And then this is the RFID module, and it's connected with the Arduino with SPI bus, and this SPI interface has the defined pin for Arduino Nano. This pin is defined. I have to connect the SDA pin, or serial data pin, with the digital pin 10, and serial clock pin with the digital pin 13 of the Arduino Nano. And the MISO is defined as digital 11, MOSI is defined as digital 11, and MISO is defined as digital 12. I can change this connection, so this schematic may look a bit complicated, but actually I have nothing to do with this. Likewise, there is a LCD display, and we have connected this LCD display with an I2C module. This I2C module has 4 connectors, 1 2 3 4, these 4 connectors, and the connection for these pins are also defined. The SPI module for I2C communication, we need the analog 4 and analog 5 pin of the Arduino Nano, so we can change these pins. This portion of the schematic may also look a little bit complicated, but actually we can't change it as the Arduino doesn't support. And then this is the keypad connection, and there are 4 pins for the column and 4 pins for the rows. Actually, in our project we have used a 4 into 3 a matrix keypad, but I have designed it for 4 into 4 matrix keypad, as connecting a extra pin makes it possible for both 4 into 4 and 4 into 3 keypad connection. So it doesn't matter if I don't connect this or connect this, it will not. And this is the connection for the keypad. This is connection for 4 into 4 matrix keypad. We can also use 4 into 3 matrix keypad with this connection, and just we have to ignore this connection, or just do nothing for this connection. And look, the analog 0 pin is connected across the row 1 pin of the keypad. Analog 1 is with row 2, analog 2 with row 3, analog 3 with row 4. and this column 1 C1 I have designated it this C1 is here. So this C1 and this C1, these are actually shorted as the designation is the same. So the column 1 is connected with the Arduino digital pin 2, and column 2 is connected with the Arduino digital pin 3, column 3 with digital pin 4, and column 4 with digital pin 5. We have connected the buzzer pin with digital pin 7 and lock signal with digital pin 8. Here is the buzzer as a lock signal, this is the lock signal, and this is the buzzer signal. There are two registers. Actually the value of these registers can be changed actually according to the performance of the buzzer. And this PC817, this is an optocoupler. Basically it can be simmed from this portion as an LED. So this circuit has two LEDs. One LED is the standard red LED, and one LED you can say typically this is an IR LED. So what this LED does, when it is turned on, it emits light, and this is an phototransistor. There is a phototransistor across this pin number 4 and pin number 3. This phototransistor turns on when this LED is on. As the phototransistor turns on, this path is shorted, and I have drive the BJT with this terminal. So what actually this do is, there is no electrical connection, there is no direct electrical connection with the Arduino and the relay. Actually the relay or lock module may create a noise, a fluctuation of voltage and current, which may destroy the Arduino or ATmega 328P microcontroller. So I haven't taken any risk. I have connected an optocoupler. It's better if the supply can also be separated, then the ground separation will be possible, the full ground separation will be possible. And there are several types of ground separation. I will not talk about this in this video. Okay, I have used BD 135 for driving the relay. I have already tested and showed you guys that this works as the relay works with this BJT. So there is no need to waste more money for better BJTs or MOSFETs, or if it is whatever. And there is a diode. This can be a 1N4007 model diode, or it can also be a 4148 high speed switching diode. Whatever, this is a flyback diode. What an flyback diode does, it protects the circuit from the relay, or the relay when it's turned off. There is surge current or back EMF, and which risks the circuit, external circuit. So it actually shorts the path when the circuit is turned off. It actually shorts the path and protects the external circuit. There is also a flyback diode across the buzzer, because the buzzer also acts somewhat little bit like a relay, but there is less possibility to damage the circuit with this buzzer, as it is very low. It draws 20 times less current than this relay. But for protection I have also added a buzzer, but as this buzzer only draws 35 milliamps of current, there is a little bit of risk. So I haven't connected any optocoupler or opto isolator with this buzzer, and the signal is come through here across the register. The base is driven through this resistor, through this path, and the current is amplified. And sometimes you may find many circuits in the internet where these uh, uh, these transistors are not used. What happens then is that the buzzer is not operated with its full capability. The buzzer can draw 35 milliamps of current, but the resistor is connected in such a value that it's limited with 20 milliampere current or less, so it beeps less loudly, which is not likable for me. So I connected a BJT to drive the buzzer, and that's all about this schematic. And I have designed several PCBs for this project. Actually, as you guys know, there is a fabrication limitations in our country, so I have to design several times these PCBs, and now this design is almost perfect, and I think there shouldn't be any problem to fabricate this PCB from any local PCB manufacturing plants. However, thanks all.